Okay, so let us see chessboard and queens problem. The first key point is we need to place 8 queens on chessboard so that no 2 queens attack each other. So this is the first key point. And the second key point is, as an additional challenge, it is top of the first key point. It is on top of first key point. Each square is either free or reserved, and you can only place the queens on the free square. But the reserved square do not prevent queens from attacking each other. And what we need to find? We need to find how many possible ways are there to place the queens. Let's just focus on for the 8 queens placed on chessboard so that no 2 queens attack each other. We will focus on the first key point. The second key point we will see later. So the first key point reminds me of the problem n queen, which says that place n queen on an n cross n chessboard so that no 2 queens attack each other. So to deal with the first key point, we're gonna study the n queen problem in detail, in depth, and then later on we will build the logic to satisfy the second key point also. So let's get started. Okay, so the queen is placed here, and the queen moves are row, column, and diagonals. That means you can't place the other queen on the same row, that means this blue one, or in the same column, that means the green one, or the diagonals, the left and the right. So diagonals. So we should gonna avoid the these three, and we'll build the logic accordingly. Okay, so let's study for n equal to 4. That means we have 4 cross 4 chessboard, and we're gonna analyze for this board. Though the problem has mentioned in for n equal to 8, but we're gonna study for 4 cross 4, and we'll build the logic from here. So here is the 4 cross 4 chessboard, and here is the first, second, 3 and 4 queens are there. As told, we are gonna not place in the same row, or not in same column, and not in diagonal. So we are not going to place in the same row. That means if suppose the queen is placed here, the other queen would definitely go on the second row. That means we're going to increase the row. So this will come here in this and this and this. So this is how we're going to deal with the will not place in the same row, and also not in the same column. So this is column number 0, 1, 2, 3. For n equal to 4, we got these columns, these 4 columns, and will not place in the same column. That means if the queen is placed here, then we will do something like we will create an array of size n, and we will mark this 2. That means this satisfies that this queen has been placed in the 0th column, and you should not place the other queen here. We will see how we're gonna build the logic of this, but this is how I'm telling you a rough idea how I'm gonna deal with this. And for not placing in the same diagonal, if the queen is placed here, then you can't place the other queen in this diagonal. Or let's take another example. Let's say if the queen is placed here, then you can't place the other in this diagonal. This means is this right diagonal, or the left diagonal means this. So we need to find some trick to track down these diagonals. If the queen is placed here, how we're gonna track, okay, this diagonal is being occupied. For this, let's move on the next slide. So here we're gonna see for right diagonal, here is our chessboard, and these are these indexes. And right diagonal, this is the first right diagonal, and these are its subsequent diagonals. Okay, so we have these diagonals, and let's number them. This is 0, 1, 2, 3, 4, and 5, 6. Now if you thoroughly see this, you may get an idea. This is 0th, this is first, second, and third. So by adding these row and column, we can get the number. For instance, let's take the example of this. Alright, so how are we gonna get this 2? By adding this row and column, right? This is 2, 1 plus 1 is 2, and here by adding row and column means row is 0 and column is 2, so we get this. Here row is 2 and column is 0. So basically if we just add the row and column, we can track down the right diagonal, right? Let's take an example. Suppose a queen is placed here. You want to check for the right diagonal. How are we gonna do this? we gonna add the row and column. So this is 1 and 3, that means 4. This means diagonal 4 is this, so it is being occupied. How are we gonna write the code of this? Like we did in the column, we created an array. Same also we will create a right diagonal array, and suppose if I place here, then 4 I will mark it true. That means this diagonal is being occupied, the fourth diagonal is being occupied. This is how we're gonna do. But here the main thing you need to understand is how you're gonna track down the diagonals. So this is how we're gonna track down the diagonals. Similarly, let us build the logic for left diagonal also. We have the chessboards, and these are left diagonals, and these are its marking. Now to track down the left diagonal, if you see, we can get this, let's take this one. We can get this by adding 1, subtracting the row from the column. So that means 1 minus 2, row is 1, column is 2, so and adding 3. So this is going to result in 2. And you need to do some little bit effort here to get this. So this is how, after some few trials, we got this an idea how we are going to track down the left diagonal. So we can track down by row minus column plus 3. So if a queen is placed here, so row minus column, that means 0 minus 0 plus 3, that means 3. This line is being occupied, this diagonal is being occupied, you can't place the other here. So, and for general n, we can say row minus column plus n minus 1. This is for general n. So this is how we're gonna track down the left diagonal. Okay, so here again, this chessboard, these queens, told we are not going to place in the same row, same column, and not in same diagonal. Okay, so let us do manually how we're gonna trace this chessboard. So we will keep the first queen, let's say here. So as told, we will not place in the same row, so we'll go in the next row. Can I keep it here? No, column 0 is being occupied. Can I keep this here? No, because left diagonal, because of left diagonal, so you can't keep it here. Can I keep it here? Yeah, we can keep it here. Okay, move over. Can I keep it? No, because of column. No, diagonal. No, column, diagonal. Okay, so this queen doesn't got any position and it has finished the last column. You can't go ahead. So we'll take out this, we'll go back and we'll reconsider our solution again. So are you getting any idea? We are going back and reconsidering our solution. So that means this is backtracking. Yeah. So now what we're gonna do, we're gonna increase the column. Can I keep this queen here? Yeah, you can keep, no problem. Okay, we'll go ahead in the next row again. Can I keep it here? No. Yeah, you can keep here. No column, no row, no diagonal issue. Alright, let's go for the next row. As soon as you have kept it, as soon as you have kept this, we will go to the next row. So can I keep this? No, 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 because you can't place this queen anywhere and you have reached the column end. So go take out this, go back, reconsider your solution for the previous queen. Can I keep this here? No. Can I keep this here? No. Again, take out this because you have reached the end, reconsider the previous solution. Okay, can I move? No. So take out this, go back and reconsider your solution. Okay, so we'll keep this here. Now can I keep this here? No, no. Yeah, you can keep this here. Can I keep this here? Yeah. Can I keep this here? No, no, no. Alright, now you have successfully formed one solution, and this is a one way, one of the ways to place the queens. And now this was manually. Now we will in the next slide we will try to build the logic for this. So what we are using, we are going back, that means backtracking, and this backtracking is achieved by the recursion. Okay, so here's the chessboard, and how we gonna trace this on a code, how we gonna write this on a code. So we will create a column array, a right diagonal array and a left diagonal array, and we will number them according to the chessboard. We will see how we gonna create that size of array which is required. So yeah, for 4 cross 4 we have this. And why I have created a right diagonal of size 6? Because you see right diagonal and left diagonal went till 6, so that's why I have created till 6. So now what does this mean? This means if a queen is here and you place in the, let's say you place here, you wanna place here, so you are placing on column number 1, so you are gonna go there and make this true. That is specify that you are using this column, so no other queen will be placed here, because this is true, the queen is placed here. Initially everything is false, and this comes the left diagonal, so this is the left diagonal. And how we gonna trace the left diagonal? I told you row minus column plus 3. So row is 1, column is 1, so 1 minus 1 plus 3, so this is 3. So that means you will go left diagonal and will make this true. That means this is specified the left diagonal is being used. Similarly also for right diagonal, row plus column, so 1 plus 1 is 2, so you will go there and will make this true, right? Because this was right diagonal and it was 2, right? This was 0 1 1, so 2 2 2, so you have made this true. And this is how we gonna proceed. Okay, so let's try to manually do it. So we have the chessboard, we have all these arrays which told in the earlier slides. Now let's start placing the queens. So I am here placing the first queen. We can place because initially everything is false, so no issue. Now we will make the column 0 true because I have placed the queen here. Now the left diagonal is this. And how we can get left diagonal? Row minus column plus 3, so 3, so this is 3, right? Remember, and this was 3, so we'll go there in the left diagonal, right? This is left diagonal, so we will go at place 3 and we'll make this true, specifying this has been used. And for right diagonal, this is right diagonal which is 0, row plus column, so row plus column 0 plus 0, this is true. This queen has been placed and we have successfully did for first queen. Now we'll increase the row and we'll pick this queen and we'll check now. Can I place in column 0? No, the queen is placed and column 0 is true. Okay, increase column, so column is increased. Now here I am here. Can I place? Yeah, column 1 is empty, it is false. Now we'll check for the diagonals. Right diagonal 1, yeah, for right diagonal what we're gonna do? Row plus column, 1 plus 1 2 is false, so it is, you can keep here. Okay, we'll check for left diagonal. How we're gonna check for left diagonal? Row minus column plus 3, so this result 3 with 3. No, it is true, you can't keep the queen here. Okay, increase column again, so now the queen is here. Again check column is 2 is empty, and row plus column 1 plus 2 is 3. Right diagonal, it is false, yeah, we can keep here. And for left diagonal, 1 minus 2 plus 3, which is 2, so go to 2, yeah, it is false, we can keep here. So what I'm gonna say, we will make this column true and the left diagonal also true, and the right diagonal was 2 plus 1 3, so this will true. Okay, go back, no, not go back, increase the row, because we have find this solution for this, so increase the row and we'll pick the next queen, which is this. Okay, can I keep it here? No, because column 0 is true. Can I keep it here? Okay, we'll check column 1, it is empty. For right diagonal, 2 plus 1 3. No, you can't place because the right diagonal is being occupied. True it is. So okay, increase the column. Can I keep it here? Column 2, check for column. No, it is true, you can't keep here. Okay, increase the column. Now I'm here. Can I keep here? Okay, we'll check. Column 3 is false. Okay, you can. Right diagonal is 3 plus 2 is 5. Okay, it is false, you can keep. And for also we will check for left diagonal. So this will be 2 minus 3 plus 3. So this is 2. Oh, it is true, you can't keep here. Okay, take out this queen, go back and increase the column for this, and don't forget to make the things false. So we will increase the column, and also we will make this false, because now this queen is here at 3. So we'll make this true and we'll make all these false, and this was for 2, right? 2. So we'll make false all these values. 2 plus 1 3, it is again false, and we'll do for we'll place this queen here. So that means column 3 will make this true, and this is which diagonal? This is this right diagonal, left diagonal is 1 minus 3 plus 3, that means 1. So left diagonal, this will be true, and for right diagonal 3 plus 1 4. So we'll make this true, and we'll go next. Like this we're gonna do, and this is how we're gonna proceed again and again. And when we have successfully placed the last queen, that means row is, we have successfully placed the last queen, that means that is one of the ways. Alright, so what we are doing, this is a piece of code written. Let's try to just analyze. If we are checking for empty, right, we are checking for the empty condition for column, it is false. 0 means false, left diagonal and right diagonal. If it is false, that means we'll place the queen at that position and we'll make things true, and we will go next. We will put next means we will go to the next row, and we'll try do this. And if things are not good, we will make the things, we will put back the things back to false. Okay, so let's write the code of this, and there we will have a better understanding. Okay, so we need to place 8 queens as they have mentioned on a 8x8 chessboard, and this is the input. Okay, so let's make as a general n, and we'll initialize it with 8. Now we will create a string chessboard of size n, since because they are giving this, and yeah, we haven't taken care of the second key point, which is tells the additional challenge. We'll see. So let's do this, and we'll create the right diagonal, left diagonal. So this is right diagonal, and what should be the size? Let's see this. Now when n was 4, we created a size up to 5. Okay, so n was 4, we created right diagonal, the size as 6. How can we get this? I can say that 2 into 4 minus 1 will result in 6, right? So for n equal to 8, we will result in 8 minus this will result in 14. So we can define a general like this. So we'll create the array of size this. Okay, so 2 into n minus 1, this is, and left diagonal of same size 2 into n minus 1, and column of size n only, and we need to do false. So the default value is false only. So default value is false. Okay, now you see these squiggly lines here, squiggly lines, or whatever you call this. So this is because the array has to be of constant size and not a variable. So as it says, the value of variable n. So let's make this data type constant by adding const. That tells it is a constant, and we will get rid of these lines. Okay, so we need also create the number of ways, as we need to count and initialize with 0. Okay, so let's write our function first. We'll write void put next, and it's gonna accept row, because remember we are manually shifting the row. So int r, that means row. Now what we're gonna do, we will transverse the column. So we'll say int c as 0, and we'll transverse this up to the size, so n, and will increase column. Now as told, we will check if it is empty, and then we're gonna keep. So for this we will say if column c is equal 0, that means it is false, and the right diagonal and left diagonal. So left diagonal can be by adding this row and column, right? How we were doing, left diagonal is row minus column plus 3. Okay, left diagonal is row minus column plus 3. So row minus column plus 3, and for general we can say 3 can be added by n minus 1. So we'll write n minus 1 is equal 0, and right diagonal is row plus column. So row plus column, right? Right diagonal was row plus column. Simple. So if these things are there, then what we're gonna do, we are good to place the queue, right? If these are false, we can place the queue here. So we'll make the column C, the left diagonal r minus c plus n minus 1, and the right diagonal r plus c as true. That means we are keeping the queue in here, and we'll go next. We'll call this function again for r plus 1, increased row. And also now we need to count the number of ways. If we have finished off the column, then the function will come back here only, and it needs to make the things back to false. So we'll write this false here. Okay, and if we are able to find a solution, which was this, so we have increased the row, right? So the next row will be row plus 1, that means 4. So now it is done. We have found a solution. So what we will say here, we will say if row is equal n, that means that is our base condition. Stop here. Now you have found a way. So we will increase the number of way and will return, and it is gonna return here. We'll make the false again, and again we'll find a solution for this. And let's now get the input, how the input is. So we'll say int I should be less than n, and we'll see in chessboard I. So we are putting here, and at the last we need to display the number of ways here. So, and before that we need to call this function also. So we'll call with value 0, right? We will start with from row number 0, and we'll display the number of ways. And now you see, is either free or reserved. So this star represent it is reserved, so you can't place the queen here, but for the dot you can keep here. So I will just add an additional condition here only, saying that if chessboard row and column is equal the dot, right, I can place. And I hope you are understanding this, what I have written here, this as in a 2D form. Let me explain here and why these squiggly lines are coming again. Squiggly lines. Okay, so let's figure out why this is coming. I should put here 0 0 to make it consider false. And yeah, I was explaining this, so let me explain here. So we are inputting a string, right? A string chessboard, and a string itself comes in index form, right? 0 1 2 3. So what I'm saying is, if I am inputting this and I'm going up to 8, right, up to n, so this will be first string, second string, and it itself comes in the indexes form. So if I write chessboard 2 and 1, that means I am saying that 0 1 2 3 up to 8, the second row means this, and the first means 0 1. So I am saying this one is either free or occupied. That's what I have written here. So okay, so I think we are done. Let's submit this now. And okay, so submit. Okay, so it has been accepted. And okay, so let us trace the function which we have just devised, put next, for n equal to 4. So we will start with 0, and initially all the setup, everything is set to false, and we are beginning. So r is not 0 is not equal to 4. We will start the loop. So here we are, c is equal to 0 and r is 0. Now since this is the beginning, everything is false, so we are gonna put the first queen, which is this, over column number c, which is 0. So column 0, this will be true, and we are at row 0, column 0, so the queen will be put here. This queen, first queen, will be put here, and we'll make all these values true. So left diagonal will become true. So left diagonal is 3, right? If I do left diagonal was row minus column plus 3, so 0 minus 0 plus 3. Okay, so left diagonal will be 3, this will be true, and right diagonal, which is 0, row plus column, this will also be true, and our first queen is placed here, and we'll now move for put next row plus 1. So put next r plus 1, that will be 1. So here we are at r is 1, and it is not equal to 4, so we will come here, column is 0 here, and we'll see, is column number 0 is 0. So no, it is not 0, it is 1, it is true. So this is not going to execute further, because this is an any 1 0 will will result in 0. That means it is false. So we'll go c plus plus, c will be 1 now. So c will be 1, and now we're gonna check, is this true? Yeah, it is false, is equal to 0. Column 1 is false, and we will check for left diagonal and right diagonal. So we are here and at row number 1, and we are here. So we will check for left diagonal and right diagonal. Is left diagonal would be r minus c plus 3, right? So r is 1, column is 1 plus 3, so left diagonal 3. We will check for left diagonal 3. Is it false or it is false? No, it is true. See, so we're gonna move further. So this will become 2 now. So we will be here. Now we will check. Is column number 3 false? Sorry, column number 2, right? So column number 2 is false. Yeah, it is false. And we will check for left diagonal, right diagonal. They are also false, right? We are here. So we're gonna keep the queen here. The next queen. So this queen will be kept here and we will move further. So now we will execute this line. Put next 2. Now we are here. Again we will start. From row is 2 and column will be 0. Can I put it at 0? No, because it is filled. And yeah, we have not changed the value. We should do that. When we were here at this row number 1, we should make this true, right? Because we're gonna execute this condition and then we're gonna move further. So we will make this true. This is I'm doing for row number 1. We forgot to do this, and we will do for left diagonal, right diagonal. So right diagonal would be 2 plus 1 3. So this will be true, and left diagonal would be 2, right? So this will be true now. Okay, so we were now we are going to execute for row plus 1. So row 1 plus 1 will be 2. We will be here now. So can I put here? No, because column 0 is not 0, it is 1. Can I put it here? No, because of diagonal issue. Can I put it here? No, because of diagonal. No, because of column we can't. Column is occupied. Can I put it here? We will check. No, because of left diagonal, right? You can't put here. So now column will, so we can't place at 0, can't place at 1, can't place at 2, and not even can place at 3 also. So this has executed. It will go to the calling function. So it will go back. So it will go back and will execute this one, right? Because it will go to the previous call, and now it is gonna make everything false because this was wrong. So we'll make the false here. So this will all be false. Again back to set to false. So this will be false, and even 2 plus 1 3. This will be also false, and this will also be false, and column plus plus, and so we will remove this and will go here. Can I put it here? Now column plus plus will be there, so column will increase, column will become 3 here. And can I put things here? Yeah, because everything looks alright. No column issue, no left diagonal, right diagonal issue. So we'll make here this true because I'm keeping here, and 3 plus 1 4. This will be true, and the right diagonal would be 1. So this will be true. Now we'll move forward, and again we'll call this for row plus 1. So we'll be here, and again we'll start putting. So can I put it here? No, column issue. Can I put it here? Yeah, everything seems alright. So we'll put here, and we'll mark here everything true. So column 1 would be marked true. Column 1 will be marked true. What else? 2 plus 1 3. So 3, which was false, right? It was false. So we'll make it true. And what else? The left diagonal would be here 4. So 4 will be true, and we'll move forward. So now we'll be here, and we will place this queen. So we'll move forward with put next 3. Now we are at row 3. We'll start with column 0. Can I put it here? No, because column 0 is true. Can I put it here? No, because column 1 is also true. Can I put it here? You can, but there is a diagonal issue. Can I put it here? No, because there is a diagonal issue. So we'll go back. This function has finished calling 0 1, and didn't find any position, so it will backtrack again, and will make false every here. Will make false will make false here, so this will be false again, and 2 plus 1 3, this will be false. And what else need to be false? The left diagonal, which is 4, this will be false. This was 4, right? Now we'll increase column plus plus. Can I put it here? No, because of diagonal issue. Can I put it here? No, because of diagonal issue, right? Because of the column issue, sorry, because here column issue. So we'll move even backtrack more, and will be here now, and this will be removed from here. Everything will be changed here false, and we will increase can C plus plus. So this will be 4. Now it can't go, so this will even backtrack again. So it will be here now, right? And everything will be set to false. We are doing that. Everything is set to false, and we are here now. Now this will be at this call, C will increase. C was 0, this will be 1, and I need to reset it. So let me just erase it and start a fresh one. Okay, so I have made all the changes. We are now here, and I have set all the values true, which correspond to this block. Now I have made this true. Now we'll move forward with put next r plus 1. So r plus 1 will be 1 here. Can I put it here? No, because of diagonal issue. We are here. Can I put it? No. Can I put it here? No. Can I put it? No, because of diagonal. Can I put it here? Yeah, you can put it here. So we'll make column 3 true. And what else? We need to make the right diagonal, right diagonal 3 plus 1 4. So this will be true, and the left diagonal. So left diagonal would be row 3 minus 1 plus 3, right? Row minus column. Okay. So row is 1, column is 3, and plus 3. So 1. So we'll go here and make this 1 true. Okay. Now we'll move forward, because now we'll move put next. We are here. Can I put it here? Yeah, because everything seems alright. So we are putting it here. So we'll make this true. We'll make the left diagonal 5, which will be true, and the 2 plus 0, so 2. So we'll make the right diagonal true. Now we'll move forward. So put next 3. So we are here now. Can I put it here? No. Can I put it here? No. Can I put it here? Yeah, because no issue. So we'll make this true, and we'll make the left diagonal 4 true, and the right diagonal would be 2 plus 3, that means 5. So we'll make this true, and we'll execute this. Put next 4. So we'll go here. So 4 is equal to n, right? So we'll increase the number of ways. So number of ways would be increased, and this would be set increased to 1, and we'll return back here, and we'll make things false again. We'll make things false again, and again we'll try to find another different pattern or solution to this, and we'll keep on doing this until we have exhausted all the solution. So this was a complete explanation of the problem. We started with the logic building, we explored the example, and we wrote the code also, and now finally we are done with the try and run of our function. You can also do it once for a better understanding, and do this on your own, so you will have a belief that you can handle these backtracking solution, and they are not tough. We just need to work on the procedure, and you have to just find the repetitive task, and then you can easily solve the problem. Alright, so I will meet you in the next video. Till then, take care and bye.